So in this one, we have the graph of f of x, just, not really something that came from an equation, but drawn on this graph. The function g of x is given by -2 f of x. So when we produce the graph of g, we see that we have a vertical stretch of 2, and also we have a negative in front of the function, which means that we're going to reflect it in the x-axis. So in effect, what's going to happen to the points is first we're going to double the y values. So I'm actually going to graph this in 2 steps. I'm going to do red for the first step and blue for the second step. And there are ways to do both. So a vertical stretch of 2 is going to take all my points. For example, these 2 points have y values of 3. So I'm going to move them up to 6. This one has a y value of -2, so I'm going to move it down to -4. Y value of -3 here, so I'm going to move it down to -6. So this shows my initial transformation, and these transformations are kind of interchangeable. I'm just going to erase this side because it looks a little ugly. But of course it is not letting me right now, so we're just going to have to leave the one side. Let me see if I can get this. Not looking that great. Okay. It does not want to let me erase that piece. Okay, so I chose to do the vertical stretch first. I could have done the reflection in the x-axis first because they're both kind of in the same spot. So now we're going to take each of these points, reflect it in the x-axis means I'm bringing it up to the other side of the x-axis. So this is at -4 for y, I'm going to +4. These two that are at 6, I'm going to -6. So 2, 4, 6. It's a little hard with a stylus. And then this one is at -6, so we're going to come up to +6. So as I said, not the prettiest graph, but this is where your graph g of x is. Now to find out the next question where f of x equals g of x, that is actually at these 2 points on the y-axis. They're just asking for the values of x. This equation means we know the y's are equal where the x is equal when I say f of x equals g of x. So those x values are this one right here, if we count back, is -5 and +3. So we could say these as x values, we could write them in our set notation, either way is fine. The next one asks me whether or not this is an even or odd function. So we're going to use an algebraic method for this one, which means that if it's an even function, it's going to be true that it's symmetric over the y-axis. So that means that f of x would equal the graph after a reflection in the y-axis, which is the rule f of -x. So I'm going to write f of x, the function, over here. And f of -x means that I'm just plugging in negative x's for the x's. So this is going to be -x to the 4th minus 8 over 4 times -x. So this side will stay the same. That's like our checking side. And over here, this is going to become positive because we're raising it to an even power. But on the bottom, it becomes -4x. So these two are not equal. So we're going to say it's not even. Okay. To check for odd, our rule is a rotation of 180, which is the same as reflecting in both axes. So we're saying f of x equals -f of -x. Now, if you remember from the unit, here I'm just going to take what I already found for f of -x, and I'm going to make that negative. So we're going to put a negative in front of x to the 4th minus 8 over 4x. It's going to be a little tricky because it's a fraction, but we'll work through it. So over here I have x to the 4th minus 8 over 4x for just the regular f of x. So this is like having a -1 here over 1. I'm going to distribute it to the numerator. So that gives me, and I made a mistake here. I missed this negative sign when I copied it over, so let me just put that on. So this is going to give me -x to the 4th plus 8 over -4x. And over here I have x to the 4th minus 8 over 4x. Okay, so when we distribute the negative, we just distribute it to the top. Now the question becomes, are these two the same? So looking at this, if I factor out a -1, I'm going to have to come down here. I get x to the 4th minus 8 over 4x. If I had taken that -1 and put it on the bottom, it would have been more obvious. But basically here, when I look at this, if I change all the signs on the fraction, which I'm allowed to do, it's like dividing the top and bottom by -1, we do get that they are equal. So this is an odd function. And this is also a tricky one because usually we can look at the variables to tell if it's even or odd. And we have an x to the 4th, which would make me think it's not odd. But when I divide that by 4x, if I was going to distribute, that would give me x cubed. When I divide 8 by 4x, I would get x to the -1. As I said, also kind of tricky, but if you want to, like, if you're trying to make sense of this, and you remember a lot about that unit, so x to the -1 also has an odd exponent, making this also make sense that it's an odd function. Okay. So we're going to look at this focus problem, and this has to do with thinking of the parabola as a geometric figure. So a parabola, just to put this like a little bit oversimplified, a focal point is something that a parabola bends around. Okay, so you can think of it like it's sending out its two sides, bending around it. So the focal point is at 0, 10. And then on the other side, there's this thing called a directrix, which is here. So the vertex of the parabola is always in between these two things, and it bends around the focus. So it's going kind of like it's in between, actually, exactly. If we measure any points on the parabola, they're the same distance from this line and that focal point that it bends around. The vertex is always in the middle and always bends around the focus, not around the line, which is the directrix. So this gives me a point of 0, 5 here. Okay, so looking at which equation is correct, all of them look decent. The y-intercept of these is 5, 5, and 5, so this is not the answer. So this, and also this one, do you see how it goes down? So that's also not the answer. So just getting that idea of bending around the graph gives you down to 2 answers, even though we didn't spend the 2 days on that lesson. So there's an equation that looks like this, 1 over 4p times x minus h squared plus k. H and k are just the vertex, so that's where we get our x minus 0 squared plus 5. Okay, so that's why it's either 2 or 4. The p-value is the distance from the vertex up to the focus in that direction, so that's a 5. Okay, so there's 5 difference, so it's 1 over 20 here, because 4 times 5 is 20. So, as I said, I'll probably make a little lesson of that if you're interested, which is something we decided to cut because it's not really connected with other topics. The last one, definitely important, is find the inverse. So we're going to switch x and y. So we get x equals 4y minus 2. And then we're going to solve for y. So I'm going to add 2 to both sides. 4y equals x plus 2. And then divide by 4. So I get y equals x plus 2 over 4. I don't see that answer. So I am going to split it up and write it in mx plus b form. So that's 1/4 x plus 1/2, which matches up with choice number 1.